Hi folks, today I bring you the front panel of the Blaupunkt car radio model Milano MP28. It uses an integrated circuit reference CT6523 as a driver for the LCD. We already have several videos that address the 6523, and as they are identical, we will highlight the use of the keypad and the rotor knob. The keypad itself is based on the two buttons K1 and K2, where each button is associated with a resistance value. Thus, when the key is pressed, we insert the resistance value associated with that key into the bus. The rotor knob, in particular, has a curious and unusual use. Being a quadrature rotor knob, one would expect its use to be in that sense, but not. It has two resistors, one in each phase, which in turn converge to a common point, allowing reading only the rising and falling sides of the same point. To use the both keypad bus, two timers are implemented, timer 1 and timer 2, with the timer 1 being 16 bits and timer 2 being 8 bits. Therefore, in timer 2, it was necessary to increment a variable so that two timers would experience the trigger event at close time intervals, but in different phases, in order to leave some slack in the call for the analog pin readings. We did not respect the code safety rules by leaving multiple lines of the code within each trigger event. However, since the call for each event is spaced in the time, this will not cause us problems. Of course, I could read the ADC values within the same event, but I still think it will be easier to understand for those who are not very familiar with the code. Note that on one K-bus we have 6 keys and on the other 11 keys. If we divide the value of the 1024 by 11, which is the number of the keys present in the larger bus, we will have an interval close to 93 for each key. The principle is 5 volts DC divided by 1024 equal to 4 millivolts DC. Therefore, in the worst case scenario, we will have a range of 93 by 4 millivolts equal to 372 millivolts for each key in the reading of the pin connected to the ADC. Based on this range, we can now attribute actions to the interval values read at ADC pins. To connect the Arduino to the panel, I used the wires connected to the pin 8, 9, 10 and 11. The pin 8 will be the data, 9 clock, 10 strobe and 11 is the ANH. To read the ADCs connected to the bus of the keys, I used the ADC 0 and ADC 1. Also, I used the pin 6 and 7 to control these both LEDs here, and these both LEDs are controlled by the trigger event, and you can see they blink at different times. The interval is the same, but the phase is different. Also, I have the pin 4 and 5 to control the LEDs blue and white, and these both LEDs are controlled to the keys connected to the bus 1. For example, this key here, if I press the LED blue bright, the second bus will bright the white, and if I press again switch off. These are only two check the correct working of the bus of the keys, but of course you can use another things.